Welcome to Spring LIB.
In this exercise, we're going to need the concepts of force and acceleration. So let's briefly review these concepts before diving into the exercise. So first, we need to remember that according to Newton's second law, the sum of all the forces that act on a body, which we call net force, is equal to the mass of the body times the acceleration. And also, the acceleration is equal to the first derivative of the velocity with respect to time. Okay, so with this information, we can proceed with the exercise. So in our problem, we have a block A that has a mass of 50 kilograms and a motor B that exerts a certain force on a rope that connects B to A. This force exerted by the motor F is equal to 100 times t to the 3 halves newtons, where t is the time. And we also have the information that the coefficient of static friction between block A and the surface is equal to 0.4, while the coefficient of kinetic friction is equal to 0.3. Given this information, our goal is to find what is the velocity of block A after a time of 5 seconds has passed. Okay, so in order to proceed with the exercise, we need to take some steps first. So first of all, we need to find at what time the block starts moving. So the block is initially at rest. That information is given to us by the problem. And at some point between 0 seconds and 5 seconds, the block starts to move. We need first to find what is this time. Okay. Now we know that the total force, or actually the sum of the forces that act on block A is the sum of the force F that the cable exerts on A with the force of friction, which I'm going to call FF, that acts on A. When the block is still, when it's at rest, the force of friction steadily rises as the force F that's applied on the block rises. And the maximum value that the force of friction can have is equal to the coefficient of static friction, mu s, times the normal. And the normal force in this situation is just the mass of the block times g. Because remember that there is a force of gravity, mg, acting downwards on the block, and there is also a normal. So for the forces to be balanced, we need that the normal force is equal to be equal to mg. So the maximum value of the static friction is mu s times mg. So we have that the force minus mu s mg is equal to 0, since the acceleration of the block is 0, since the block is at rest. Okay, now notice that if the force increases, if the force F increases more, then the block will start moving because it has already reached the maximum value of the static friction. So at the time when the force F is equal to mu s mg, the block starts moving. So if we solve this equation, we can find what time that corresponds to. So we have t times 100 times t to the 3 halves is equal to mu s, which is equal to 0.4, times the mass times 9.8 So t is equal to 0.4 times 50 times 9.8 divided by 100 to the 2/3. So the time when the block starts moving is equal to 1.57 seconds. So let's save this because we're going to need this information. And then in the second step, again, we need to draw a free body diagram of the block A. So we have force F and the force of friction, which in this case is the force of kinetic friction, and this is equal to the mass times the acceleration. Now the force of kinetic friction, let me just substitute F by 100 times t to the 3/2, and the force of kinetic friction is mu k times mg. Okay, so we have 100 t to the 3/2 minus mu k, which is 0.3 times 50 kilograms times 9.8 meters per second squared, and this is 50 times a. So we have 2 t to the 3/2, sorry, minus 2.94 is equal to the acceleration. Okay, now remember that the acceleration is equal to dv dt. So we have, if we multiply both sides by dt, that a dt is equal to dv, so we can integrate both sides. And I'm going to integrate both sides from the time when the velocity is equal to 0, which in our case is 1.57. I'm going to call it 0 to t. And in the right-hand side, I'm going to integrate from 0 to v. Okay, so in the right-hand side, we get just v. In the left-hand side, we have the integral from 1.57 seconds to 5 seconds of a, which is equal to 2t to the 3/2 minus 2.94 dt, and this is equal to v. So I have 2 times 2/3 t to the 5/2 minus 2.94 t from 1.57 seconds to 5 seconds, and this is equal to v. This is the speed v, the velocity v when t is equal to 5 seconds. So now all we have to do is to substitute the numbers. So we have 2.2 divided by 3, I'm sorry, 2 times 2, not 2.2, sorry for that. Because the integral of t to the 3/2 is 5, I'm sorry, is 2/5 of t to the 5/2. I'm sorry for the mistake. Here, it should be 2 times 2, or 4/5 times t, the final t, which is 5 to the 5/2, minus 1.57 to the 5/2, minus 2.94 times 5 minus 1.57. So v is equal to 32.2 meters per second, which is the velocity we were looking for.